I saw this question on binomial expansion, and I feel it would be great I share with you, my audience. It will help us understand combination, logarithm, and binomial expansion itself. That said, let's get into class. Welcome back. Question wants us to find the value of x if the third term in the binomial expansion of 1 plus x raised to power log base 2x raised to power 5 is same thing as 2560. Now, if you look at this expression, 1 plus x raised to the log of x base 2 all raised to power 5, I can equate it to this general expression of x plus y all raised to power 5. Now, using binomial theorem, my x plus y all raised to power 5 should look like 5 combination 0 x raised to power 5 raised to power 0 plus 5 combination 1 x raised to power 4 y raised to power 1 plus 5 combination 2 x raised to power 3 y raised to power 2 plus 5 combination 3 x raised to power 2 y raised to power 3 plus 5 combination 4 x raised to power 1 y raised to power 4, and lastly plus 5 combination 5 x raised to power 0 y raised to power 5. From this expression, we'll concern about the third term from this equation, from the question. Now, this is the first term, the second term, and here is the third term. This is where our concern is. Now, that is the third term, 5 combination 2 x raised to power 3 y raised to power 2 is given as 2560. Now, if this is given as 2560, first and foremost, let's start by finding 5 combination 2. 5 combination 2 is the same thing as 5 factorial over 5 minus 2 factorial times 2 factorial. Now, this is the same thing as 5 times 4 times 3 factorial over 3 factorial times 2 factorial. 3 factorial divides 3 factorial. And 2 factorial is same thing as 2 times 1, that's 2. 2 here is 1. 2 in 4 here is 2. So that 5 combination 2 is given as 10. That means that 10 x raised to power 3 y raised to power 2 is the same thing as 2560, which implies that x raised to power 3 y raised to power 2 will be the same thing as 256. We know that x is the same thing as 1 from this expression, and y is the same thing as x raised to power the log of x base 2. So that x raised to the log of x base 2 all squared, because we have y squared, will be given as 256. Obviously, we can go ahead and find the square root of both sides. If I find the square root of both sides, I'll raise this to half. 2 cancels 2 here. Then I'll find the square root also of 256. So that x now raised to the power of x base 2 will be the same thing as 16. The square root of 256 is 16. Let's open another slide. Now, if x raised to the log of x base 2 is equals to 16, we can simply introduce logarithm on both sides to base x, and introduce logarithm on this side also to base x. Let's remember that if I have the log of a, or probably of b base a, where b is raised to power c, this is the same thing as c, the log of b base a. So that we'll be saying that this is the same thing as log x base 2 log x base x is equals to log 16 base x. 16 is the same thing as 2 raised to power 4. I can interpret that as 4 log 2 base x. Now log x base x is the same thing as 1. So if this is 1, obviously I'm left with log x base 2 equals 4 log 2 base x. Now if you look at these two expressions, or if you look at both sides of this equation, you see why I have log base 2 here, I have log base x here. I want to make both base the same thing. Remember that if I have log a base b and I want to change this to probably log 2 base 10, I can interpret this as log a base 10 divided by log b base 10. So we apply the same principle here, so that log x base 2 should be the same thing as log x base x over log 2 base x equals 4 log 2 base x. Log x base x is the same thing as 1. And cross multiply log 2 base x here to multiply log 2 base x times 4. That's what I'm simply saying. Log x base x is equals to 1. That is 1 over log 2 base x equals 4 log 2 base x. So that 1, if you cross multiply, becomes, this is 4, let me write it out, times this log 2 base x times log 2 base x. Can obviously divide both sides by 4, so that I have 1 over 4 equals log 2 base x all squared. Now, if we take square root of both sides, you see that taking square root of both sides, I'll take square root of this side, and same thing, I'll take square root of this side. This becomes half equals 2 here 1, 2 here is 1. Log 2 base x. Now if half is equals to log 2 base x, or let's write it appropriately, log 2 base x is equals to half. Obviously 2 is equals to x raised to power half. Now we can now raise this to power 2 and raise 2 to power 2. 4, 2 here is 1, 2 here is 1 is equals to x. So the value of x for this expression is equals to 4.